Okay, today we're going to learn how to find the definite integrals. And these definite integrals, normally they are known as integrals with the limits. And we have to see that how to apply the limits to the integrals. For this purpose, we should be very good at the techniques of integration. Okay, now let me tell you how do we do that. I'll be starting with the very simple examples. Now, suppose you have to integrate um, 2x plus 1 and you have been given the limits from let's say 1 to 3. Okay, so you will integrate this. First of all, this is going to be 2x square over 2, that is x square plus x, and this time we don't need to write plus c, but I will be writing that plus c for the very first time so that you know that why don't we write this plus c here. Acha ji, so the limits are here from 1 to 3. The first thing that you need to see that once you're done with the integration, you will change all these integration signs with the square brackets here, okay? And now you will be applying the limits. So this is your f of x over here. It is, if you look at this, you have to apply this rule over here. So first of all, you will find f of 3. So that is going to be 3 square plus 3 and then plus c, and then minus, next you will be writing f of 1, that is you better use the brackets here. This is 1 squared plus 1 plus c, so this is 9 plus 3 plus c minus 1 plus 1, that is 2, and this is minus c. Since this c is eventually cancelled out, because you can substitute this, because you know that if you have f of x that is equal to 2x plus 1, suppose you have f of x that is 2x plus 1, and you want to find f of a, or let's say f of 5 for example, so this 5 has to take the value of x, so this becomes 2 into 5 and this 1 comes as it is, this becomes 11. Therefore, when you're applying the limits here, the terms which have x in it, they are very important over here. But and if you have any constant, that will be cancelled out. So that is why we don't need to write this plus c when you have to apply the limits. But writing this plus c is equally important when you don't have to apply the limits. So please remember this. So now suppose you have to integrate and then apply the limits, and the question is, suppose you have something like let's say you have limit from 0 to 4, okay, and there is 2x plus 1 cube, let's say this is like this, okay, or raised to power minus 3. Okay, so first of all you need to integrate this. So this is limit from 0 to 4, and its integral here would be um, 2x plus 1 raised to power minus 2 over minus 2 into 2. Okay, a bit of simplification before we apply the limits to it. That is minus 1 over 4 into 2x plus 1 whole square. Now you have to put these limits here. So first of all, I'll be putting 4 into it. That is minus 1 over 4 into, this is 9 square minus, and then I put 0 into it. This is minus 1 over 4 into 1 square, and then you can simplify this. I'm just going to leave it up to this. Okay, now let me show you, let me take you to the exercise, and you will see that what kind of questions do you have here in the exercise. um, so we are to be on exercise. Where is the exercise? Here is the exercise. Come on, ma'am, exercise. Where are you? Let me put that on a pause here. This is the exercise 15.8. So let me do some questions from here. I'll be doing first of all question number one's part F. Okay, so you have limit from 1 to 4. This is 2, and I would write it as 2 plus 2x is per minus 2. Okay, so just to give you a recap of the integration, I'm doing all these questions. So this is the form that I can integrate. This is limit from 1 to 4. This is 2x plus, now 2x is per minus 1 over minus 1. So that can be written as minus 2 over x. Okay? So we apply the limits into it. I'll be substituting 4 first. This is 8 minus 2 over 4. Then I put 1 here, 2 minus 2. So this is going to be uh, 16 minus 1 is going to be 15 over 2. That is 7.5. Okay. That is the answer to one part F. Okay. Let me do question number 2 part F now. Guys, you will have to be quick. You can take the screenshots. You can uh, do whatever you have to copy them down. Okay, so I'm going really in a fast mode because you people have done all this differentiation, okay, sorry, integration. The only thing you people are learning, that is how to apply the limits. Okay, I'll be doing question number 2 part F next. Okay, 2F, it says limit from -4 to 0. This is 6, and I would better write it as 4 minus 3x raised to power minus half. The first thing is always that you have to write that in a form in that we can really integrate. Now, I just shifted that under root 4 minus 3x to the numerator so that I can integrate it. Remember, we are not allowed to integrate anything that is there in the denominator. Acha, now I'm going to write this 6 outside here. So 6 limit from -4 to 0. This is going to be 4 minus 3x raised to power half over half into -3. And this gives me, I can cancel out this 3 with this 6. So I have -4. I'm writing this -4 outside from -4 to 0. And I'm left with under root 4 minus 3x, on which I have to apply the limits now. ठीक है बच्चों, do ask me if there is anything that is creating a trouble for you. Now, when I put the 0 over here, I get under root
सर
4.
ये -4 कहाँ से आया जो आपने बाहर लिखा है?
Look at this, beta, this minus here, this minus, and this half. The reciprocal of half is 2. So -2 into this 2 will make this 4 here. Okay? This -2 into this, because this is basically 2 over minus half. So that will give you -4. Got it, beta?
जी सर, थैंक यू।
Okay, beta. So please keep on asking. Don't be worried with the speed I have. Okay, you can apply the brakes at any time. Okay. Acha. Now I put the lower limit here. So 4 plus 16, 4 plus 12. That is going to be 16. Okay. So that is going to be minus 4 into 2 minus 4. That is going to be 8. This is your answer. That is 8. Acha, Bacha, there is one thing about the square root. Remember, if you are applying the square root yourself, for example, you have something like x square equal to 4, and you apply the square root on both the sides, and you write it like this, then this has to be x equal to plus minus 2, okay? But if the square root is already there and the signs are predetermined, then you don't be confused with why, like, thinking or saying, oh, should I write plus minus here or not? This square root is already there. This is not what you people have applied here. Okay? So this will remain as it is. There is no need to be worried about the signs here. Okay, so this is going to be 8 over here. You will be trying all these questions from question number 1 and 2, all the parts here. Now I'll be doing one part from the third question. Let me do that. Which part? Maybe I part. H or I? Tell me any one of these two. H or I? Hmm?
Sir, H करना.
H. Okay. So 3H. So this is limit from 0 to 1. Now you see there's a power square on it. If there is a power on the brackets, what kind of expression can there be inside the brackets? Tell me quickly. Hmm? Hurry up. What kind of expression is allowed inside the brackets with the
Sir,
power?
denominator will be allowed.
No, no. The thing is, this, if you people are integrating and there is a power on the brackets, so this expression can only be, it can only be a, come on, yaar,
Linear.
linear. Look at all the parts of this question number two. They are all linear. Can you see the powers in the brackets? But the expressions, they are all linear. Okay. Therefore, it is not a linear expression. It is an exponential kind of a function here. So we don't like this. So we'll have to expand this. Okay. Let me expand it here and then I'll be putting it there. Now this is 3e raised to power x squared minus 2 into 3 e raised to x into 2 over e raised to x plus 2 over e raised to x whole square. This is your a square minus 2ab plus b square. Okay. Now I'm going to write it here. This is 9 e raised to power 2x. This e raised to x cancel with the e raised to x. You have 12. This is minus 12. And this is 4 over e raised to power 2x. And I would be writing it as 4 e raised to power minus 2x. So guys, you have to simplify your expression into the form that you can really integrate. Now we can integrate. This has become a very sharif bacha now. This is limit from 0 to 1. So this is 9 e raised to power 2x over 2 minus 12x plus 4 e raised to power minus 2x over minus 2. Okay, we are ready to apply the limits into it. Okay, so when I put 1 into it, I get 9 over 2e square minus 12 minus 2 over e square. And when I put 0 into it, I should uh, use these brackets here. So remember, e raised to 0 is 1. Okay. So this is 9 over 2. 12 into 0 is 0. And this is going to give me minus 2. This is it. Okay. So we have 9 over 2 e square. Um, this is going to be 4.5, 2.5 minus 2.5. This is minus 14.5 and minus 2 over e square. That should be our final answer if I haven't made any silly mistake here. Okay, please have a look at it, keeping this table of typical values in front of you. You can easily try these questions from the fourth part here. Okay, so let me make some space for this fourth question. Acha ji. Okay. So you were saying I'll be doing two parts from this. Okay. So one is always, you people are afraid of the last part. So 4f. So this is limit from pi by 4 to pi by 2. Acha. You should not be writing both these limits to the left like here. Okay. If you write one to the left, other should be written at the top. Otherwise, the recommended way is to write both the limits towards the right of this integral sign, like one limit here, the other limit here. Okay. Don't write both the limits to the left of this. Okay. So this can be penalized if you write your limits to the left. So I have just got used to writing like this limit from A to B. So um, this is a bit acceptable, but the best way to write is you write it like this: limit from A to B. That is the appropriate way of writing it. Okay, limit from A to B. Acha khair. So limit from pi by 4 to pi by 2. This is sine 3x minus cos 2x dx. Okay. So just try to recall, how do you integrate sine and cos? So this is just a one step thing here. This is pi by 4 to pi by 2 here. Now, once it is integrated, you can write it anywhere, by the way. This is minus cos 3x over 3 minus sine 2x over 2. Okay. Now your calculator's mode should be in radians if you want to do that um, using the calculator. Acha, now let's put the limits here. This is minus 1 over 3 cos 3
I
pi.
have a question.
Yes, Dave.
So you decided है ना that whenever we get questions like this in the radian में करना, or is it told in the question that we need to do the values in radian?
Whenever you see this pi thing, that means your calculator mode should be in radians. And remember, in your additional mathematics, for most of the times, your calculator has to be in radians mode, okay? You will rarely have to use your calculator in degrees mode in your additional mathematics paper. Please remember that, okay? Acha. So this is minus, and this is going to be minus 1 over 3 cos 3 pi by 4 minus half sine 2 pi by 4. Okay. Now these angles are going beyond pi here. Don't worry. Uh, 3 pi by 2. If you people remember that pi is same as 180 degrees. Okay. So you know that pi by 2 refers to 90 degrees. So 3 pi by 2 refers to 270 degrees. And if you remember, your cos is 0 here, 1 here, 0 here. Sorry, this is your sine. This is how your sine is, and this is how your cos is 1 0 minus 1 and 0 here. This is how your cos behaves. Okay, plus plus minus minus plus plus minus minus. So cos 3 pi by 2, that is cos 270, that is 0. Okay, so this is going to be 0, and sine, this cancel out with this, sine pi is also 0. Okay, minus cos 3 pi by 4, that goes in this quadrant here, okay, with the basic angle pi by 4, that is going to be minus 1 over under root 2. This is minus 1 over 3 into 1 over under root 2. And then this is also, this is pi by 2. And you know that sine pi by 2 is 1. This is minus half. Okay, finally your answer is 1 over 3 under root 2 plus half. That is your answer. Okay. The next is 4e. So this is limit from 0 to pi by 4 2x minus sine 2x dx. Okay, so limit, this can be integrated within one step here. 2x integral is going to be x squared. Remember, 2x squared over 2, 2's cancel, you're left with x squared. And this one is going to be cos 2x over 2. Achha, while applying these limits, what happens is when we see, oh, we have 0. So we think that when you put 0, everything is going to be 0. But remember, in case of exponential, for example, if you have e raised per x kind of thing, so what is e raised per 0? That is 1. Similarly, what is cos 0? That is also 1. So be very careful while applying the limits with this exponential thing or with this cos thing. Okay. Now, when you apply the limits here, this is going to be pi over 4 squared plus half into cos 2 pi by 4, and then minus. When you put 0 here, 0 square is 0 plus half cos 0. Okay, so we have pi square over 16. This is cancel out with this. We know that cos 90 is 0. Cos pi by 2 is 0. And from here you have cos 0. This is minus half. So this is your answer in exact form. You can use your calculators if you want to give the answer in decimals. So the very last example for this, we can do one part from question number 5 quickly. So let me do that 5a maybe, or yeah, they are all the same. Okay, so limit from 1 to 5. This is 3x plus 1. I'm not writing this 2 intentionally over it. I want a 3 here. Okay, so I'll be writing it as 2 over 3 into 3 over 3x plus 1 dx. I hope you understand why I have done this? Hmm? Why did I move 2 out and introduce 3 here? Hmm? Hello?
Yes, sir.
Why did I take 2 out and brought 3 in? Because the derivative of 3x plus 1 is 3. I need 3 up here. ठीक है ना? Because I'm applying the rule here that if you have f of x in the denominator, you should have f dash of x up here. And then this would become ln f of x. ठीक है? I hope you understand this. This is 2 over 3 ln 16 minus ln 4. Yes, ln 4. And applying the logarithmic rules, you can write it as ln 16 over 4. Finally, your answer is 2 over 3 ln 4. I have applied the quotient rule here. Okay. So guys, that is it. This was about applying the limits to the given integrals, which is called the definite integrals. It is time for you people to practice all these questions from here, from this exercise 15.8. Okay, thank you very much.